So for this video I created this small scene. It's just a modified first-person template that comes with Unreal out of the box. If you create this and press play, you'll be able to walk around. Now to add sprinting ability, first we're gonna go to Edit Project Settings, and in Input Bindings, under Action Mappings, we're gonna add a new action. We're gonna call it Sprint and bind it to left shift by clicking this button on the left. Now in the viewport you can select our first person character and press Ctrl E to start editing it. Right click in the event graph and search for our sprint input action. It's gonna fire when we press or release the shift key. On the left, you can see all of the components that this blueprint has, and this one component in particular, called character movement, as you might have guessed, is responsible for character movement. To use it in our graph, we can just drag it anywhere with Control key pressed, and on it we can search for set max walk speed. We're going to connect it to our pressed execution pin, and let's set a value of 800. Now, if we select this node and press Ctrl W, a copy of it will appear under the cursor. Here we're going to set a value of 400 and connect it to our released execution pin. Let's also set target here to character movement. And now when we click play, we'll be able to press shift to speed up. Now, adding stamina will require a little bit more nodes. And instead of bloating our first-person character blueprint, we're going to create a new blueprint alongside it in the content drawer. Right-click, Blueprint class, and select Actor component. Let's call it BP for Blueprint, Sprinting component. Let's remove all of this because we're going to move it to our new component. And let's move our component into the hierarchy here. Now double-click our new component. Click Open Full Blueprint Editor. And as you can see here, this blueprint has its own event graph, its own set of functions, macros, variables, etc. And this is very good because let's say you had a lot of different abilities. Sprinting, crouching, climbing, being able to press buttons, and so on. If you just edit all of that into one blueprint, your graph would become bigger and bigger. You'd have more and more functions and variables. And sooner or later, it would become very hard to work with. So this logic here will be nicely isolated from our first-person character blueprint. And since it's isolated, we now need to explicitly get all of the things from first-person character blueprint that we want to work with. With getOwner function, we can get the containing actor of this component. It's going to be first-person character in our case. If we right-click the return value pin, we can promote it to variable, which means to just save it for later use so that when we need the owner, we don't have to call the getOwner function over and over again. We're going to call this variable just owner. And on our owner, as you remember, we have a character movement component that we're going to need here. We can get it with getComponentByClass function. Here we can select character movement component class, and we'll also put this into a variable. Let's connect the execution pins. And on our character movement component, we're going to get max walk speed and put it into a variable too. All of this is going to fire once when the component is created. That's what event begin play means. We can select all of this and press C to add a comment. Now to actually add sprinting functionality, we're going to right click and add custom event. We're going to call it sprint, and then we're going to add another event and call it stop sprinting. Now in our first-person character blueprint, we're gonna drag the sprinting component into the graph. And when the sprint action is pressed, we're gonna call sprint on it. And when it's released, we're gonna call stop sprinting. And the reason why we're doing it here and not in our component is because only actors can react to input events, which is perfectly fine. It's actually quite convenient to have just one graph that wires all of the input logic together. Now back in our component, we're gonna create a new variable B sprinting, B for Boolean. We can drag it into our graph with Alt to set it. On sprint event, we're setting it to true, and on stop sprinting, we're setting it to false. And this is actually all that we're going to do here, because actual logic that's going to decide if we're going to be sprinting or not is going to execute on tick, which means every frame. Let's drag our sprinting variable into the graph. And with branch node, we can check if it's true or false and do different things for those two cases. Depending on whether or not it's true, we want to set character movement component max walk speed to different values. However, instead of putting values directly into these set nodes, we're gonna create a new variable and we're gonna call it speed multiplier. And it's gonna be of type float. And so if we're not sprinting, if we're not pressing shift, we're gonna set it to max walk speed variable, which is just our default walk speed that we got from the character movement component. And if we are sprinting, we're gonna set it to max walk speed multiplied by speed multiplier. Let's compile the blueprint and set speed multiplier's default value to 2. We can press play to make sure that it still works like it did before. So on tick, we're going to be doing multiple different things. And to keep it clean, let's select all of this, right-click, and collapse to macro. We're going to call it update movement speed. As you can see, our node has no output execution pins. And so we won't be able to actually do something after this macro executes. To fix that, let's double-click it and drag both execution pins on these setters to our output node. Now for our fatigue system, we're going to need some variables. Current fatigue is going to be a float that holds a value from 0 to 1. When it reaches 1, we're going to stop sprinting. And then we'll also have fatigue rate and fatigue restore rate. These will define how fast we are fatiguing and how fast we are restoring. We can create a separate category for these three to keep things organized. And let's also not forget to assign some default values. For fatigue rate, it's going to be 0.2, for restore rate, it's going to be 0.4, and current fatigue is 0 by default. On each tick, every frame, we want to take our current fatigue value, and we want to gradually move it to either 0 or 1, depending on whether we are sprinting or not. This can be done with float interp2 function, and we're using specifically float interp2 constant, which means interpolate with constant rate, with constant speed. So the value is going to change by the same amount every second. But we're going to execute this every frame and not every second. And to take frame rate into account, as you can see, this function accepts delta time, which tick event conveniently provides for us right here. And the interpolation speed is going to change from fatigue rate to fatigue restore rate, depending on whether we're sprinting or not. To do that, we can use the select float function. Here, if sprinting variable is true, it's going to pick A, which is fatigue rate. Otherwise, it's going to pick B, which is fatigue restore rate. Lastly, we need to specify the target. As I already said, it needs to be 1 if we're sprinting and 0 if we are not sprinting. If we just plug our sprinting variable into the target, we'll get just that, because Boolean converted to float gives you either 0 or 1. Now we can set current fatigue to the return value of the interpolation function. This is our fatigue logic. We can collapse it to macro and call it update fatigue. As you can see, we have a couple of problems here. One problem is that we don't have an execution pin on the right side of the macro, which means we can't execute anything after it, and we can't update our movement speed, and we can't sprint. And the second problem, which is a much bigger problem, is that wires here are crossed, which is very bad for my OCD. Luckily, we can fix both very easily. Double-click, drag a wire to outputs, and then select the inputs, and in Details panel on the right, reorder your inputs. Now to actually make fatigue affect our movement speed, we'll open our update movement speed macro, grab our current fatigue and see if it's less than 1. Or rather, let's compare it to almost 1, because we're dealing with a float here. Strictly speaking, there shouldn't be a problem with comparing to 1, 2, because we're interpolating with constant rate. But you just never know, maybe later you decide to interpolate with non-constant speed. And then it will become a problem, and then you will have to remember that you did it here, so it's just better to just do it to begin with. This comparison will tell us if we are not completely fatigued. And so if we're not completely fatigued and we are trying to sprint, then we're gonna go faster. Otherwise, we're gonna use the default maximum walk speed. Before we test it, let's add a simple UI so that we can see our current fatigue level. Let's move our sprinting component to its own folder. And here in this folder, we'll also add a widget blueprint class. We'll name it widget blueprint sprinting. Here in this widget, we're going to add a progress bar. We'll set its anchor to the center of the screen, reset its position, set alignment to 0.5 on both axes so that it's perfectly centered, and then just offset it on Y a little bit. In progress, you can change % to see what it looks like. I'm going to make it narrow. And what I also want to do is to get rid of this diagonal pattern on it. To do that, I'll create a new material. In its properties, I'm going to change material domain to user interface, then create a constant with one left click and plug it into the final color. To make it white, I'm going to set the value to 1. Now we can drag this material into a fill image. And finally, under appearance, we'll change the fill color to white too. Let's rename progress bar to fatigue bar. And make sure that is variable here is checked so that we can access it later. To actually add it to the viewport, search for create widget. Select our new class that we just created and add it to the viewport with add to viewport function. And actually we also want to save it to a variable because we want to change the progress bar value from our blueprint. Add a comment to keep it nice and tidy. We can also add a comment to this. And to actually change the progress bar value, we need to grab the sprinting widget, get fatigue bar on it, and call the set % function on it. Set % takes a value from 0 to 1, which is really good for us, except we want our progress bar to be filled when we are not fatigued. So we want the opposite of what we have in our current fatigue variable. To get that, all we need to do is to just subtract it from 1. Let's collapse it to macro and call it update widget. We can press play to make sure that it's actually working. So it's all working pretty well, but as you can see, the progress bar stays on the screen even when it's not relevant. We want to hide it when the fatigue value is 0. Let's go to our widget and add a new animation here. I'm gonna call it fatigue bar fade in. Now with this animation selected, let's add a new track for our fatigue bar, and on it, let's add a new track for render opacity. If we press this button here, it will create keyframes for us. In the beginning, let's set render opacity to 0, and then sometime later, let's set it to 1. As you can see near render opacity, the value is changing smoothly, but visually it's not the case. The reason for that is that in our material, the blend mode needs to be set to translucent, and now it's working. Now in the top right corner, you'll see a button to switch from designer view to graph view. We're not going to be using any of the default events here. Instead, we'll create a custom event called show and another event called hide. On the left, you'll see our fatigue bar fade in animation. We can call play animation forward function on it when show event is triggered and play animation reverse when hide event is triggered. And another small thing that we need to fix in Designer is when you deselect your animation, you'll see that render opacity, that the default value for render opacity is not 0, but it's 1. We want to change it to 0. Now back in our sprinting component, in update widget macro, we want to check if current fatigue is almost 0. And if it is almost 0, we want to hide our widget. We can do that, of course, by calling the hide event on our sprinting widget that we just created ourselves. And if it's not, we want to show it. But remember, this is going to be called on each tick, so each frame. And we surely don't want to show our widget on each tick. We want it to happen only once when fatigue gets to 0 or stops being 0. To do that, we can use the standard do once macro. And after we trigger hide or show event, we want to reset the opposite do once node. Basically what it means is that after we showed our widget, we can't show it anymore until we hide it. And after we hid our widget, we can't hide it anymore until we show it. It may be a bit hard to understand at first, but it makes it easy to track state changes without introducing any additional variables. Now, if we test it, we'll see that the progress bar is only on screen when it's not full. Now, if you're really observant, you may have noticed a problem. After we press play, in the first 200 milliseconds, we can see the hide animation playing. Luckily, it's really easy to fix. We just need to start the upper do once closed. So now it's working, but there's also another problem that we need to fix. If you press play and just press shift without moving, you'll see that we're still fatiguing. And that's because we're only checking if sprint action is pressed or not. What we should do instead is get our character movement component and get its velocity. Velocity is a vector that describes speed and direction of movement. It's basically 3 speeds: X speed, Y speed, and Z speed, all stored together in one data structure. However, we're not interested in direction here, we're only interested in speed. We need to get just one speed from it. And to do that, we can call vector length on it. Let's check if our speed is greater than 50, and if it is greater than 50, and if we're sprinting, if we're actually pressing sprint button, then we're going to be fatiguing. We can select all of this, collapse it to a function, and call it isFatiguing. Since we don't need any execution pins on this function, we can make it pure by clicking this checkbox here. And let's also rename our output. Now if we press play, we'll see that the problem is gone. And in case you're wondering why we are comparing our speed to 50 and not to 0, that's because now we can sprint into a wall. So we're going to wrap it up here. There are still things to improve and there are still edge cases to consider. Like for example, now we can sprint in all directions, not only forward. And depending on what type of game you make, you may or may not want to fix it. I'd say for a general purpose component, it's probably a good idea to implement that check and then make it optional via a Boolean variable. Also, the whole fatigue system, for that matter, can be an opt-in thing. So there are definitely things to improve, but I think we got ourselves a pretty good foundation. So I hope it was helpful, and I'll see you in the next one.